determine if the following equation is exact. If it is exact, find the solution. So this is in the form m dx. Here is the standard form if you want to compare. M dx plus n dy equals 0, and this is exact if my, the partial derivative of m with respect to y, is nx. So this is mxy, a function of x and y, and this is nxy. Okay, now we find the partial derivative of m with respect to y. So derivative of sine y is cosine y minus sine x. This is a function of x, vf's like a constant. So sine x times derivative of y is 1. It's just sine x. Now let's find the partial derivative of n with respect to x. So cosine x, derivative of cosine x is negative sine x plus cosine y behaves like a constant. Cosine y times derivative of x is 1. So this cosine y minus derivative of y is 0, because we are trying to find with respect to x, and this behaves like constant. So this, and look at these two, they are same. Cosine y minus sine x, cosine y minus sine x, they are same. That means this equation is exact. Okay, and now we want to find the solution. Then there exists f such that the partial derivative of f with respect to x is m, the first part. So sine y minus y sine x. Let's write 1, equation number 1 for future reference. And partial derivative of f is to be determined. Okay, uppercase f is to be determined. Y equals cosine x plus x cosine y minus y. And once we recover the function f, here is the solution. Fx equals c. That f equals a constant is solution. Okay, now we can integrate 1 with respect to x, or we can integrate 2 with respect to y. So it looks like 1 is slightly easier, so let's integrate 1 with respect to x. Integrate equation 1 with respect to x. So fx dx equals sine y. In fact, sine y behaves like a constant when we are integrating or differentiating with respect to x, minus y sine x dx. This is the function f as xy. Now let's find the antiderivative of sine y with respect to x. So this is constant, so survives constant, and times 1, and antiderivative of 1 is just x times x, so I'm writing x here, minus y is constant because we are integrating with respect to x, minus sine x. Antiderivative of minus sine x is cosine x, because the derivative of cosine x is sine x. So this becomes plus y survives as a constant and cosine x, okay, plus some constant of integration. In this case, y also behaves like a constant, so we need to write hy. This could be a pure function, pure constant, just the real number, or a function of y alone. Okay, let's say this is 3. Now we found f, and the solution will be f equals c. Okay, this is the solution, but we need to determine h, and as we see, we have not used 2. Okay, equation 2. Now let's find the derivative, partial derivative of 3 with respect to y. Then we can compare with 2, and we hope we will find hy by this way. Okay, so differentiate 3 with respect to y, f with respect to y. So with respect to y, x is constant, derivative of sine y is cosine y, plus with respect to y, this is cosine x is constant, derivative of y is 1, so 1 times cosine x, that's cosine x, plus now derivative. This is a pure function of y, so the derivative is h prime y. Now we compare 2 and 4. Okay, from there we get fy is same in the left side. That's why we can compare. Cosine x is cosine x, x cosine y is x cosine y, so h prime y is negative y. Okay, so compare 2 and 4 to get h prime y is equal to negative y. Okay, this is a pure function of y. Now we integrate both sides with respect to y. So this is a pure function of y, so we should have only function of y in the right hand side. If there are x terms, that means we made mistake earlier. Okay, let's integrate. So this is hy, and this is negative 1/2 y squared plus c, but that will be absorbed later, so we don't need to write plus c. You can write if you like. So now we substitute h back in equation 3, and we have the function f. Thus the solution is the function f equals c, which is now x sine y plus y cosine x plus hy is in fact negative 1/2 y squared equals c. Okay, final. This is the solution of the given exact differential equation.